Hi, welcome everyone to the online course on Essential of Database Management System. In previous videos lecture, we discussed introduction and application of database management system. In this session, we are going to discuss basic terminologies of database. We will discuss one by one in detail. What is the database? It is a collection of organized data that is stored and can be easily accessed, managed, and updated. And next one, database management system. It is a software that enables the user to interact with the database. It provides tools for creating, managing, and querying the databases. And next one is table. What is the table? It is a collection of data organized in the row and column. The table are the basic structure in the relational database. And next one is row or record. A single entry in a database table that contains data related to specific entity or object. For example, student's entity where we can type the student detail. For example, roll number, name, section, department as a record. And next one is the column or field. A vertical section in the database table that represents a specific attribute or property. A column holds the data for a particular aspect of the entity. For example, student is a entity where we can create number of columns. For example, roll number, name, section, or department, etc. And next one is a key. Key are one of the basic requirements of relational database model. It is used to identify the tuples, that is the row, uniquely in the table. We also use the key to set up the relation amongst various columns and table of the relational database. There are different types of database keys. Primary key, candidate key, super key, foreign key, alternate key, composite key, artificial key. We'll discuss one by one detail. What is the primary key? There can be more than one candidate key in a relation, out of which one can be chosen as a primary key. For example, in the employee table, the employee number as well as passport number, license number was the candidate key for the relation employee. But the employee number can be chosen as a primary key. It is a unique key. It cannot be null. It can identify only one tuple or records at a time. It has no duplicate values. It has unique value. The value in the primary key column can never be modified or updated if any foreign key refers that primary key. For example, we will take one table, that is employee table. Here, employee number, passport number, and license number is considered as a candidate key because this column only the unique. So employee name and employee address, the duplicate it will occur. So we are selecting only employee number, passport number, license number as a candidate key. Among, we are going to select only one column as a primary key in order to identify the records. And next one is a candidate key. A candidate key is the attribute or set of attributes that can uniquely identify a tuples. Except primary key, the remaining attribute are considered as a candidate key. It must contain unique value. It can also contain null values. Every table must have at least single candidate key. A table can have multiple candidate key, but only one primary key. For example, in this employee table, so employee number, passport number, license number, this unique column is considered as a candidate key. Super key. What is a super key? It is the attribute set that can uniquely identify a tuple. A super key is a superset of candidate key. Adding zero or more attribute to the candidate key, generally super key. Super key value may also be null. For example, here the primary key, candidate key, and the alternate key is a composite of super key. Sometimes we will take employee number and employee name as a super key in order to identify the records. Foreign key. Foreign key are the column of the table used to point to the primary key of the another table. Example, so in this table, we are going to decompose into two tables, employee table and department table. In the employee table, employee number is the primary key in order to identify the records in employee table. In department table, the department ID is the primary key in order to identify the department detail in the department table. So now the department ID is primary key in the department table. It is acting as a reference in the employee table to make the relationship between two tables. So that is called as foreign key. Alternate key. The total number of alternate keys is total number of candidate keys minus primary key. The alternate key may or may not exist. If there is only one candidate key in the relation, it does not have any alternate key. At least minimum 2. The formula is alternate key equals total number of candidate key minus primary key. So in this table, what are the candidate keys there? Employee number, passport number, license number. That column only the unique value, right? So here among, we are going to select only one as a primary key. So what is the primary key here? Employee number. So what is the formula? Total number of candidate key minus primary key. So what is the remaining key? Passport number and license number. It is the alternate key. So the primary key and alternate key, this composition, it provides the candidate key. Composite key. Whenever the primary key consists of more than one attribute is known as composite key. For example, sometimes only one column is not sufficient to identify particular record. In that cases, we'll take one more attribute we will compose in order to identify the record. For example, order ID is not sufficient to identify. We will take one more parameter, that is attribute product ID. This composite key used to identify the particular records. Artificial key. What is the purpose? To uniquely identify each record. This type of partial key in the DBMS is unique because it is created when you don't have any natural primary key. For example, the primary key, which is composed of teacher ID, teacher role, subject ID, is large in teacher relation. So it would be better to add new virtual attributes to recognize or identify each tuple in the relation uniquely. And next one is schema. What is a schema? Structure or blueprint that define the organization of the data in the database, including tables, field, relationship, and constraint. And index, the data structure that improve the speed of the data retrieval operation on the database table. For example, if you are referring any book, first you will go to the index page. Why we are going to searching index page? So we can improve the speed of searching, right? We can directly go to the particular page with the help of the index. Similarly, the database also use the index to improve the speed of the data retrieval operation. Data dictionary. It is a centralized repository that stores metadata about the database. What are the metadata information? Tables, columns, data type, and the relationship. And next one is the relational database, a type of database that use the table structure to organize the data. It makes the relationship between tables or defined. And next one is the structure query language. It is a programming language used to managing and manipulating relational databases. It includes commands for querying, update, and managing databases. What is the query? It is a request, right? Request for data retrieval or manipulation from the database. The queries are typically written in a query language like SQL. After designing our database, next we must do the normalization. It's the process of organize the data in a database to eliminate the redundancy and improve the data integrity. And next one is the transaction. What is meant by transaction? The sequence of one or more database operation treated as a single unit. The transaction ensures the consistency, integrity of the database. And last one is ACID, that is atomicity, consistency, isolation, durability. These properties that guarantee the reliability of the database transaction. If you are developing or designing any database, you must meet the ACID property in order to improve the reliability of the database transaction. First one is the atomicity. What is the atomicity? It ensures that transactions are treated as a single unit. And next one is the consistency. It ensures that database remain in the valid state before transaction or and after transaction. Isolation. It ensures the transaction are independent of each other. And next one is the durability. It ensures the committed transaction are permanent. Okay. The next session we are going to discuss database system architecture. Thank you.